Alrighty, welcome back, boys and girls. It's your main math man, Ms. Shank, coming to you live from Summit Academy. In this video, we're working on Unit 7, Lesson number 7. Now that we have all these exponent rules down, let's apply it to some different bases. So it says we will be able to change an expression with a negative exponent and do an equivalent expression with a positive exponent. And we can use those exponent rules to rewrite an expression to have a single exponent. So that's what we're going to be doing today. So for the first part, it says which one doesn't belong with those exponents. So we could say a couple different options here. We're going to say this one has the same base with different exponents. We can say the second one doesn't belong because we can say it's the only one with single power of a power, meaning we're multiplying those exponents together. Next one, we can say it doesn't belong because it's the only one with fractions as the base. I think we say the last one doesn't belong because it's the only one with different bases. So only one with different bases. So we're just trying to say, for each of them, what is different about them compared to the other options. And then for the next part, it says we're going to have some exponent rule practice. So it says to write the following using a single exponent. So what we're going to do is we're going to remember some of these exponent rules. So we're going to say, and for a lot of these, I'm going to say, and make sure that you pause for your turn. So for these ones, for this first one, I'm going to say, I'm going to add exponents. I'm going to add those exponents together. So I can say, since I have the same base, I'm going to do 5 plus 6 in the exponent. So I say, let me write it like this. So I'm going to do 7 to the power 5 plus 6 is equal to 7 to the 11th power. I say this one's your turn, and this one's your turn. Then for the next one, I'll help you out since it's that fraction base. Same kind of setup though, so we keep the same base, but we're going to add those exponents. So I'm going to say add 4 plus 5. So I have 4, or sorry, I have the numerator is 5, the exponent, or the denominator is 6. So that means our exponent is going to be 4 plus, let me try that again, 4 plus 5. And so I can say my result, same base, again the base does not change, but the exponents I add together, so I'm going to say it's to the 9th power. For the next one, however, since we are dividing, we can say we subtract the exponents. So make sure you subtract them. So I'm going to say it's going to be 5 minus 28. So I have 3 to the power 5 minus 28. It's going to be equal to, I can say 3 to the power negative 23. So now I use that same idea. I'm going to say that the next two are your turn. Be careful on this one though, because we need to say, since again, we're still subtracting exponents. Let me write that in on that one, your turn. There we go. For this next one, I'm going to say I have 6 to the power of 5 minus a negative 8. So make sure that's almost like you're adding your exponents because I'm subtracting by a negative. So I'm going to say that's the same as 6 to the power 5 plus 8. So I'm going to say this is equal to 6 to the power 13. So now try that same idea, make sure you subtract, so it's going to be negative 12 minus a negative 20. So for this one, I'm going to say your turn as well. Now for these next 4, I'm going to say make sure you, since we're raising an exponent to another exponent, we just have to make sure that we multiply. So let me say it like this. I'm going to say multiply those exponents. So we do 2 times 3 to get our exponent of, so we do 2 or 7 to the power 2 times 3, which is equal to 7 to the power 6. We can say same idea for the next one. We're going to say we have like this. I'm going to multiply these together. So I have 4 to the power of 3 times a negative 3, which is going to be equal to 4 to the power negative 9. And then those last two, again, make sure you can do on your own. Again, make sure you can pause and check with me. Moving on to the next set, it says write the following using a single positive exponent. So notice for each of these, we're going to have to rewrite it with a positive exponent. Again, make sure you're remembering too, when we have that negative exponent, it does not mean, so let's say negative exponent does not mean negative value. Again, you might have some that have a negative value, but it's not always going to mean a negative value. A negative exponent just means small number. So the way we can write it is like this. So for example, again, rewrite. So we're going to say rewrite as fraction. So again, real simple. I'm going to say for this first one, instead of 2 to the negative 7th, I'm going to rewrite it as 1 over 2 to the power 7. So notice how I have a positive exponent, and it's just going to be the only exponent I have. Same idea with the next one. I can say, let's do orange. I'm going to rewrite it. I'm going to say this is going to be 1 over 3 to the power 23. And then same idea with part C. It says 1 over 11 to the power of positive 8. So again, it's almost like we're moving that base down to the denominator and writing it with a positive exponent. Now you try, pause for your turn, and pause. And make sure you can check with me. Moving on to that next part, it says evaluate the following. So I've got a couple different things that we're going to be doing with this. I'll make sure that I walk you through it. So again, for this first one, we're going to say we subtract the exponents. So I'm going to say I have 10 to the power 5 minus 5, which is equal to 10 to the power 0, which is equal to just 1. Again, any non-zero number to the power 0 is just 1. And for this one, what we can say is this. We're going to take, and it's almost like we're distributing that 3 to each of these. So we can rewrite it and say this is going to be equal to 2 to the power 3 over 3 to the power 3, which we're going to say this is equal to, we're going to say 2 to the power 3 is going to be 8, and 3 to the power 3 is going to be 27. So it's almost like you distribute. All right, moving on to the next one. Again, we can add exponents. I'm going to let you try that out. So it has 2 to the power 8 times 2 to the power negative 8. So that's going to be 8 plus a negative 8, which is equal to 2 to the power 0, which is still equal to just 1. So now for that third one, it's almost like we're rewriting it. We have 2 as our exponent, so we're going to say we have 5 to the second power divided by 4 to the second power, which is going to be equal to 25 over 16. So just make sure you're distributing that exponent to each of those values for that one. For the next one, we can say we multiply those exponents together. So that's going to be the same as, this is going to be equal to 3 times, or 3 to the power 4 times 0. So we're going to say 3 to the power 4 times 0, which is the same as 3 to the 0, which is equal to 1. And the last one, I can say it's going to be equal to 7 to the power 2 divided by 2 to the power 2, which is equal to 49 over 4. You don't have to change those decimals, just leave them like a fraction. All right, so now for the next one, it says mark each equation as true or false. What would you change about the false equation to make them true? And what I'm going to actually do for this one is going to use that Desmos calculator to be able to show what we're doing. So the first one, it says we have in parentheses, we have 1 over 3 to the exponent 2. And we say times, and we have in parentheses 1 over 3 to the exponent of 4. We're saying, okay, is that going to be equal to? When I say, is that equal to, and what I can do, it's going to almost change it to a fraction. I'm going to say, is that equal to 1 over 3 to the exponent of 6. So notice how I have two separate lines here, but we can say, hey, since these two numbers are the same, I can say that these two are going to be equal. So I'm going to say for this one, this first one, write this in, I'm going to say this first one is going to be true. So this first one's going to be true. So let me clear out the next one. Next one, it says 3 to the exponent of 2 times 5 to the exponent of 3. Is that the same as 15 to the exponent of 5? And so that's not going to be true. So notice how, again, these are different numbers. So when I say this is going to be false, I'm going to write false for that one. The thing that we can change about this one is we can rewrite it like this. So let me actually move this out of the way and let me say false on the problem. And what we can do is we can rewrite it like this. We could say a simple fix would be 3 to the power 5 times 5 to the power 5 equals 15 to the power 5. So if they have the same base, or sorry, if they have the same exponent, I should say, we can keep that same exponent and multiply the bases. So if they have the same exponent, we could multiply the bases. However, for the next one, it says 5 to the power 4 plus 5 to the power 5. Is that equal to 5 to the power 9? So let's check it out. So in our calculator, we're saying 5 to the exponent 4 plus 5 to the exponent 5. We're saying, is that equal to 5 to the exponent 9? So notice how I have different values, and I'm making two different lines. And since these two numbers are not the same, I'm going to say this is not equal. So this one is going to be false as well. So this one is false. A way we can change it is, since we are trying to add those exponents together, we can say 5 to the 4th power times 5 to the 5th power is equal to 5 to the 9th power. So notice how we have the same bases, we can add those exponents. And for the next one, we have 1/2. So let's have parentheses 1/2 to the exponent of 4 times 10 to the exponent of 3. Then we can say, is that equal to 5 to the exponent 7? Obviously, it's not the same, so we have to change this up. So what we can do, however, is we can say, all right, so let's say false for this one as well. And we're going to say what we can do, similar to our number 2, let's change them so that way they have the same exponent. So we're going to say, we can write it like this. We can say 1/2 to the exponent of 3 times 10 to the exponent of 3 is going to be equal to, multiply the bases, I'm going to say 5 to the exponent of 3. So again, this is some example ways of making them true. Then we go to the last one for number 5. It's going to say 3 to the exponent of 2 times 5 to the exponent of 2. Is that equal to 15 to the exponent of 2? And it is, because these are the same number. So we're going to say this last one is actually going to be true. So that one is good. So again, make sure you can see how those work. Again, make sure you're comfortable using that Desmos calculator, and be sure to ask questions as they come up. Then on the back, just some simple practice that we can have for this. So it says write each of them with a single exponent. So what I'm going to do is I'm going to tell you what the steps are. So I'm going to say for each of these, so let me write this down. I'm going to say for this one, you subtract the exponents. For this one, you multiply the exponents. For this one, you add the exponents, add exponents. Say for this one, you multiply the exponents together. For this one, again, you subtract the exponents. For these ones, since it has the same base, you can add those exponents. I'll do an orange again. So you're going to add your exponents together for this one. You're going to subtract for h. And you're going to subtract for I. So again, make sure you can, let's say, pause for your turn and check with me. So again, try those out on your own. Make sure you can use those steps carefully. Then for the next one, it says this. It says Noah says 2 to the power 4 times 3 to the power 2 is equal to 6 to the power 6. Then it says Tyler says that 2 to the power 4 times 4 to the power 2 is equal to 16 squared. Do you agree with Noah, or do you agree with Tyler? So for that first one, what we can do is say this. I'm going to say we actually disagree. So for Noah, we disagree. I'm going to say, if we write it out, we're going to say 2 to the power 4 is equal to 16, and 3 to the power 2 is equal to 9. So then if we multiply it out like they have in the beginning, we're going to say 16 times 9 is equal to 144, which is not equal to 6 to the power 6, because that is equal to 46,656. So again, big number. Again, since these two, let me circle these like this, since these two numbers are not the same, we're going to say they are not equal. Then for the next one, however, we're going to say we actually agree with this one. I'll show you why. So what we can say is, if we have 2 to the power 4, still 16, and 4 to the power 2 is equal to 16. Now we multiply those two together. It's almost like we expanded out that form of 16 squared, which is what we have here. So we're going to say this one is actually good. So make sure you can try these out, or try those ones out on your own. Be sure to ask questions as they come up. And as always, super slam that subscribe button.